Riemann sums. We learned about them in the chapter before. Now you can learn how to do them. And what is it called again? Rectangular approximation method, which is what he did. And this is the right one, this is left, and this is midpoint. You're like, what does that mean? So if we have an equation, let's just say this is like, what's a good equation?
Y equals x.
Y, no, like...
Y equals x squared.
No, not y equals x squared. This is a, like 2 to the x. You know?
Yeah.
Something to the x. I mean, it doesn't matter what the equation is. You're just learning this. Use all 2 to the x, whatever. Let's go with that. So, you got your equation, and you want to learn how to approximate it through rectangles. So if you use the right Riemann sum, and you have your points that you're supposed to use in subintervals of, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 subintervals. That means you're going to have 8 rectangles, and you want to level it to that. And depending on how many rectangles you have means how close you are. The more rectangles you have, the more close you are, you're going to get to the true area. So we got right here, and then what it means is that on this rectangle from like 1 to 2, you're going to use 2 because 2 is the right point, and 2 is what's going to be used as the y value. And as you can see on an 2 to the x, right Riemann sums is going to actually give you an over of what it is. Left is going to be the left point. So if this is 1 to 2, you're going to use 1's y value. And this is going to give you an underage because this.
You only go up to the curve from the left side.
This, and this are all not being counted, and that's part of it.
And on the right, it's overage.
It's overage because you
go to the right and then you go left.
And this, all this just went
over.
over.
So you cross over the line. While on the left, once you get to the line, you go over.
This should really be up here, but you just got all this. But midpoint Riemann sum is probably the closest because what you do, if you have 1 to 2, what's the midpoint? 1.5. So you go to y for there. And if you have 1 to 3, 2 is going to be it. So you go to 2 for there. Even though you got this over and this over, you still got this.
You got underages, so it cancels out.
It slowly cancels out. It may not cancel out fully, but you're still going to cancel.
You're going to get a more
accurate thing, and the more you get, the closer you're going to get. That's basically what those are. And you basically do as a rectangle is length times width.
And then you add them all together.
Yeah, and you just add them all together. Length times width, length times width, length times width, length times width.
And you add it all together.
And you add them all together. And I'm not going to say there's some shortcut and there's just some simple equation you can use.
There really isn't.
The subintervals can change at any time. There can be an interval of 4 to 30, and then 31 to 32, and then 32 to 40. I mean, you just had one that went from 4 to 30, which is going to be...
massive.
26, and you can't say 26 is the length for all of them, so...
You just got to do it.
Trapezoids, you know trapezoid, as you can see, it looks like there's nothing in here, but there actually is, and it's very accurate up to a certain extent, but it's probably the closest there is because trapezoids, as you know, can be bent and bent and bent until it gets close. But if this was a more steep curve, you would not be seeing as much of a closeness as there is right now. But to figure out what the trapezoids are, it's 1/2 height, base 1 plus base 2. If these are the two bases, which and this is your subinterval, let's just say 3 to 4, you're going to be doing 3 plus 4 times the height, which is right here, times 1/2. And you can keep doing that for every single one. And there is a little shortcut. If the subintervals are the same length, you can automatically just do 1/2 times that subinterval, which is the height, times this one, times 2, this one, all the way to the end one.
1 base 1, 2 base 2, because it's repeated. And then a base n.
Yeah, you just keep going and going and going.
And then the last one is just 1 base because you're only using it once.
But, I mean, you can slowly pick this up if you keep doing traps and you know how to do your things. That's basically all there is for Riemann sums and everything. They're not perfectly accurate, but they're close enough to make it seem. Good luck on your AP Calculus test.